Hello, I'm Gaurav Mahajan, and this project for DATA604, data representation and modeling, explores how representation choices directly affect decision making in machine learning. Using a subset of the MNIST dataset, the digits 39286 in 1, which were given to me, I applied both supervised and unsupervised techniques to assess how well different models and feature spaces perform. Now, as a data scientist, modeling is not just about applying algorithms, but it's also about making sound and informed decisions at every step, right from the beginning, from how we process data, pre process data, to what structure we expect our models to capture. This project emphasizes that representations aren't neutral, they shape what the model can learn and how it behaves. So, talking about supervised learning results in binary classification, the Gaussian SVM outperformed the linear SVM slightly with 99.36% accuracy, revealing subtle nonlinear structure in the digit shapes. For multi-class classification, 1v1 SVMs outperformed 1v all, achieving 95.41% accuracy and stronger per class metrics, thus confirming that finer modeling granularity leads to better decision boundaries. Talking about the next task, which is clustering and geometry, in supervised learnings, k means with k is equal to 6, the activity generated centers that resemble real digits. Hierarchical clustering with Euclidean distance revealed clear separations while L1 distance did not. Now, this demonstrated that distance metrics must align with the geometry of the data representation, which also is a critical modeling decision. Next step was to apply two nonlinear dimensionality reduction techniques. Kernel PCA with a polynomial kernel retained class boundaries well, enabling 1v1 SVMs to still perform above 88 to 89%. However, clustering failed, showing that representations tuned for classification may distort spatial relationships used in other tasks. With Laplacian eigenmaps, 1v all classification surprisingly improved, but all other methods collapsed. This shows that local structure was preserved, but global class separability, essential for clustering and binary SVMs, was lost. It highlighted that good local embedding doesn't guarantee good decision surface. Another major decision making that was involved in this project was while doing these nonlinear dimensionality reduction techniques. The original data set consisted of around 42,667 image samples, so which was computationally very expensive both on MATLAB online as well as on the system locally. So a decision was made to consider first 15,000 samples in order to carry out the tasks of dimensionality reduction. So, this project reinforced that data representation is the foundation of every model decision, whether it's kernel selection, classifier strategy, choosing a dimensionality reduction method, and considering our limitations with respect to computation. Every step is a modeling decision that shapes outcomes. So, as aspiring data scientists, we must not only evaluate performance but understand the geometry and structure our models rely on. Thank you for listening.